let's get started. All right, well, good morning, everybody. Thank you for being here. It really is an honor to be part of this conference. Thank you, Dr. Moore and Dr. Nibarte for hosting this and the pollution prevention team. So my name is Juan Marino. I'm a graduate research assistant for the pollution prevention team here at West Virginia University. And today I'm going to focus on water conservation. It is a topic that's becoming more and more critical today, especially for industry. I'm going to walk you through 5 key strategies on how to conserve water. I'm going to give some real examples, and I'm also going to show like how small actions can lead to measurable, lasting impact. So first of all, why is water conservation important? Well, globally, fresh water is becoming scarcer. Demand is expected to rise by 55% by 2050. Yet we're already facing droughts, restrictions, and supply issues in many regions. And in the US itself, the average person uses about 120 gallons of water per day. And over half of that, so 60 gallons approximately, is often used for outdoor, for landscaping, pools, water leaks, etc. We spend most of our lives at work, and therefore this is where we fulfill most of our water usage. Indeed, industries and public institutions use about 25% of the water used in major cities. The majority of all industrial water use is from the cooling of power plants, but it's also used heavily for like cleaning purposes, steam, and large portion is wasted due to just outdated equipment, inefficient processes, or maybe unmonitored leaks. So even like low cost changes can reduce consumption by thousands of gallons per year. And it is good for the environment. It comes with operational savings. And reducing industrial water conservation is like a means of addressing the global water crisis that we've been going through. And this can be achieved through a combination of behavioral change. It can be modifying or replacing equipment with water saving equipment, and maybe increasing internal reuse of the water within the operations. So let's step back a little bit here. What do we mean by industrial water conservation? Well, at its core, it is about reducing the amount of fresh water used in industrial operations, whether that's cooling systems, cleaning, or production processes. But it's not only that, it also includes improving water efficiency, not just through making equipment upgrades, but also through smarter processes and, like I said, behavioral changes. And a big part of this is also about reusing and recycling water whenever possible. This can drastically reduce how much new water a facility needs. And finally, well, it's also about, preventing waste and pollution. Now let's take a look at where water is most often used in industrial settings. So first you got cooling towers. This is where water evaporates to remove heat from processes. You have boilers and steam systems, which are mostly used to produce steam for heating, sterilization, cleaning, and various process needs. Then you got cleaning and sanitizing. This is very common in food processing industries, pharmaceuticals, and even manufacturing. You have landscaping and maintenance. Well, this includes irrigation and outdoor cleaning with higher water use, of course, in larger facilities. So by identifying which of these areas apply to your facility, you can prioritize your conservation efforts more strategically. So going back here, I missed one slide. There's just some of the most common water wasting mistakes that we see during our assessments. So the first one is like leaks in toilets or sinks or pipes that often go unnoticed, but can waste thousands of gallons a month of water. It can also be, we've seen hoses without shut-off nozzles. That water keeps running even when they're not in use. That's a lot of water waste. Overuse during cleaning and washing, especially in like food or manufacturing. And in cooling towers, improper blowdown cycles can waste large amounts of water without anyone really noticing it. And outside, Automated irrigation systems often run too long or during rainy periods where they really are not needed. And most of these issues are really very easy to fix. So it's just a matter of identifying them, knowing them there, and taking action on them. So for businesses to get started with water conservation, the first step is corporate commitment. It all starts with leadership and culture within the company. So the first thing is designating a water efficiency coordinator. So this helps ensure that somebody within the plan, the company, is responsible for monitoring water usage and identifying inefficiencies, right? Businesses should also develop like a mission and an action plan. This way, water conservation efforts are aligned with day-to-day operations. But it is true that policy alone isn't really enough. It's also important to educate and involve our employees. Reporting leaks, shutting off unused water, and sharing ideas all help create a culture of water conservation. And finally, if possible, we want to try to engage vendors and contractors. It's important to let them know that water efficiency is a priority when it comes to cooling systems, landscaping, or chemical services. And these are just little foundational steps that can help lay the groundwork for real water conservation change. So to make this more manageable, let's focus on 5 key strategies. These are actionable key strategies. They have worked in real facilities across the US and beyond. So the first key strategy are audits and monitoring water usage. This is pretty much to find where water is being wasted. How much is it being used? The next key strategy is upgrading equipment and optimizing processes. The following is reusing and recycling water internally whenever possible. Using smart water technology to track and automate water usage. And finally, tapping into into alternative water sources like rainwater and treated wastewater, for example. Now I'm going to go over each strategy and I'm going to share a real example to show how that success can actually look like. So for key strategy number 1, a water audit kind of looks like this. So first, you map the water flow throughout the facility. So this means identifying all the intake points of where water is being used, where it exists. Then step 2 is installing or reviewing. Here's the slide I was looking for. Installing or reviewing meters and sensors. And this might be ultrasonic flow meters or pressure loggers. Anything that helps kind of like measure what's happening in real time. And then step 3 is collecting the baseline data. So ideally, you log usage over like 1 to 2 weeks across systems like cooling towers, cleaning, or processed water. And after that, step 4 is analyzing the flow patterns. For here you're looking for anomalies like water spikes, like water usage spikes, idle time use, or sudden drops in water pressure that could maybe signal a water leak. And then step 5 is quantifying the opportunity. So if we know that we're losing X amount of water gallons a day, we can translate that into annual gallons and dollars saved. And then finally, step 6 is prioritizing fixes and tracking changes. But the audit doesn't really stop in the report. It ends with like an action plan and measure improvements. Now let me step back to this slide. So this is to know where water is going. Most facilities don't really have a detailed picture of water usage. So that's where like tools like flow meters, pressure transducers, like I was saying, and even thermal imaging cameras can help because you can discover things like, okay, water is running at this point at night when no one is working. Why is that happening? Pressure drops are happening. There might be a leak somewhere. There's overuse in washdown areas. So once this is measured and tracked, you can actually set a baseline, identify the waste, and build a target plan. So here's one example. This is This comes from the Metaldine plant in Michigan. They were spending about $500,000 per year on water and sewer costs. And after doing a water audit, they discovered massive losses from excessive blowdown in their cooling tower system. So what they did is they installed meters to track usage. With this, they pinpointed the inefficiency where the was being wasted, and they worked with their city to get like a sewer cost exemption. So just by doing those three little things, the savings were about $116,000 just from guiding the data and acting on it. Now let's move on to strategy 2. This is about upgrading outdated equipment. A lot of facilities nowadays still use old spray nozzles, open hoses, or high flow toilets. These can actually waste hundreds of gallons of water a day. So replacing these with low flow alternatives, adding trigger nozzles to your hoses, or switching to clean in place systems in your production lines are easy ways to like cut water waste. Even small things like retrofitting hose reels or adding shuttle valves can make a really big noticeable impact. So let me show some examples here. Low flow toilets, they use 1.28 gallons instead of a normal toilet that uses about 3.5 gallons per flush. High pressure, low flow spray nozzles, they're ideal for cleaning without wasting water. Spring-loaded hose shutoffs, they make sure water doesn't keep running between uses. And inspection is also very important. Regularly checking for clogged or leaking spray heads will help reduce waste of water significantly. Now let's put that into numbers here. Facilities that switched to chugger nozzles, they saw 60% reductions in flow. Adding solenoid valves at rinse stations eliminated unnecessary water flow, which saved over 100,000 gallons of water per year. And automating cleaning place systems, they help reduce water use by 35%. For key strategy number 3, this is water reuse and recycling. Many facilities, they use water once and then discharge it. But much of this water, especially rinse water or cooling loop overflow, can actually be reused. So you can install something like a closed loop system. A closed loop system is where water is collected, then it is filtered, and then it is reused in the same process or maybe another process within a different area of the facility or the same area. So this drastically reduces water intake and wastewater output, and some companies can even qualify for credits or reduce discharge permits. So this is what we call closing the loop, excuse me. It's treat, reuse, and repeat. Treat, reuse, and repeat. With this model, facilities can reduce water intake by 30 to 50%. With this, water and sewer bills drop. Sustainability metrics, they actually improve, which helps with certifications or company environmental, social, and governance goals. So this is just not good for the environment. It's also cost effective, and it increases increasingly expected by stakeholders. They're interested in getting some savings too. At Carlsberg Brewery in Denmark, they installed an on-site treatment system to recycle processed water. Now this plant reuses about 90% of their water, 90% of their water, cutting their water intensity in half. That itself translates to 560 million liters of water saved per year. This is like one of the biggest industrial reuse examples globally. And it shows that even high volume users can lead the way. In strategy 4, we're introducing technology. So these are smart water systems that use sensors, real-time data, and automation to monitor and control water use. With these systems, you can detect, you can alert for leaks or anomalies instantly. You can control water flow automatically with shuttle valves. You can track trends and predict future problems before they even occur. And the return on investment on these is pretty quick, especially in large buildings or large facilities with complex systems. Here's some example of the smart water management systems. You got real-time water meters. So these send alerts if usage spikes unexpectedly. You got leak detectors. These can be placed anywhere, mechanical rooms, restrooms, or basements. If they detect water, they send an alarm. And you got smart shuttle valves. These close automatically if a leak is detected. Together, these tools help reduce water waste, prevent property damage, and let you manage water proactively. Now, let me show you a great case study. A hospital had over $1.6 million in water damage from recurring leaks. What they did, they installed 40 wireless leak sensors, like the ones I showed in the middle picture, and they connected them to automated shuttle valves. Now, this system instantly detects water leaks and stops water flow before damage spreads. They're projected to save over $1 million just by preventing future incidents. Now, the final strategy, tapping into alternative water sources. So this includes rainwater harvesting, which is ideal for irrigation or cooling tower makeup, treated wastewater reuse, which is increasingly permitted for industrial processes. But I want to make a note here. It's important to check your local regulations. In many areas, using these sources can reduce freshwater demand and earn green infrastructure incentives. The EPA estimates that every person generates 50 to 70 pounds of wastewater per day. Multiply that by your employee count, and the reuse potential becomes pretty obvious. Facilities can collect gray water from sinks, showers, or final rinse cycles, and they can reuse that water in landscaping or cooling purposes. Flow meters can actually help you track volume reused and demonstrate the savings clearly. Here are some regional examples. In Fairfax County, Virginia, treated wastewater is reused for non-potable purposes, like irrigating parks, supplying cooling systems, and washing vehicles. This not only eases the demand on drinking water supplies, but it also helps the county meet water quality goals for the Chesapeake Bay by reducing nutrient runoff. In Montgomery County, Maryland, the local building code requires green roofs for rainwater harvesting systems in many new developments. And in Pennsylvania, gray water reuse is permitted for agricultural irrigation. This includes edible crops. This helps farmers cut costs and conserve clean water. So as we can see, there's some opportunities and some solutions that are already being implemented close to here. Now, measuring is really what validates everything. Here are some metrics that you can track. You can track gallons used per minute, per flush, per process. You can track total gallons saved, dollars saved, even carbon savings from heating less water. To measure these, to make some measurements, you can use flow meters, sensors, and use your utility data to build a baseline. Let's go over a really quick and easy example. So if you want to switch 50 faucets to low flow faucets, you'll be saving 500 gallons a day. That is over 180,000 gallons a year, which translates to about $1,000 in annual water cost savings, assuming a rate of over half a cent per gallon. So to recap here, first we start with water audits to understand our baseline. You look for opportunities, maybe upgrade equipment, reuse where you can, add smart controls like leak detectors and automated shuttle valves, and explore different alternatives. But it is important to track everything. Remember, you can't improve what you don't measure. Water conservation isn't just one big fix. It's about small, practical steps and good practices within your organization that add up. When done right, it is great for your budget, for your operations, and for your sustainability goals. Well, that wraps up my presentation. Thank you, everybody, for listening and for your attention. I'll be happy to answer any questions you may have. And please scan this QR code here on the screen to fill out the feedback survey. Thank you.